at similar triangles and slope today. So we have a proportional relationship here. It's a straight line through the origin. Okay? We're going to determine the slope of this line, which would also be the same as our constant of proportionality. Okay? Now, it says here we could choose any 2 points on this line and find the rate of change. So the fun thing about this is, like, you could do this completely on your own, pick completely 2 different points, and you'll get the same answer. It's pretty cool. Okay? So let's say the thing that you want to focus on, though, is making sure that you actually get points off the line that you can name. So I'm going to zoom in really close. So to show you what I'm talking about, 0, 0 is a point that we can name. Okay, it is on this line. All right, and we're looking for where this line goes through another corner, so I'll have whole number coordinates. So here's 1. Here's 1. There's 1. There's 1. Looking for where it goes through the corner. There. There. There and there. So if I were to name all of these ordered pairs, the x here is negative 16. So I'm going to make negative 16. And then the y is like 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Okay, just making sure. Negative 16, negative 12. And I'm writing that up on the side over here. This one is negative 12 and negative 9. I'm just naming the points where any of these would be ones that you could use. Negative 8, negative 6, negative 4, negative 3, 0, 0, 4 and 3, 8 and 6, 12 and 9, 16 and 12. Okay, so I've named all the points that I can name that have whole number ordered pairs. There's obviously lots of points on this line, but then that has to deal with decimals, and am I naming it exactly correctly? So that's why we like to look for where it goes through. I'm going to zoom in really tight again. See where it goes through the corner right here, and I can name that point right there with the whole number ordered pairs. This one is negative 12, negative 9. Okay? So you want to look for points that have whole number ordered pairs. Okay? So we can find the slope of this line, or the constant of proportionality of this line, from any of these 2 points. So if I wanted to, I could go in one big giant triangle from here to here. So I can make one big giant triangle by making a right triangle right there. And I can find the slope of the line that way. Okay? So let's just say that's what we want to do. For whatever reason, let's just do that. Okay? So I chose 2 points on this line, and I'm going to find the rate of change of that slope. Okay? Now, they've given you triangles here. We have triangle C. We have triangle B. And triangle A. Okay, so let's say we use these. Okay, we want it to go along the line, right? So this would go from negative 1612 to negative 8, 6. And then we could go from negative 8, 6 to, if you weren't real precise with cutting out your triangles, it might not go exactly the way that it looks like it should. Okay, so chalk it up to for scissoring skills. All right, this one goes to 8, 6 here, from negative 8, negative 6 to 8, 6. Let's see, do I have room to put this one up here? Okay, so I'd have to move this guy out of the way. So this one would go from 4, 3 to 16, 12. Okay, we could do it that way. So 2 points. Let's start with maybe something that's a little more comfortable and easy. Let's use some positive numbers here. So if I go from 16, 12 to 4, 3. From 16, 12 to 4, 3. Now I used this triangle B to do that, okay? So if I look from here at 4, 3 to 16, 12, okay, do you see here? So they've given us here, what's the height? 9. What's the length? 12. Okay, so it matches up. I have a vertical height of 9 and a horizontal height of 12. So it is y divided by x, and that will simplify to 3/4. So the slope here is 3/4. Now what if I used a different triangle? Okay, let's say I went from 0, 0 to 8, 6. Okay, so I'm looking at using triangle A this time, and I'm going to change colors so you can see where I'm talking about. So I'm starting at 0, 0. I'm going using this triangle 8, 6, and it'll tell us right here the height of this, the vertical side is 6, the horizontal side is 8, from there to there. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay, and that's to go from 0, 0 to 8, 6. So my vertical height was 6, my horizontal height was 8, and that will simplify to 3/4. Okay, 2 different points, but look what happens here. And this started off as 9/12, but it simplifies to 3/4. This started off as 6/8, but it simplifies to 3/4. So let's use this giant triangle. I'm going to use green this time. Okay, so if I go from negative 1612 to 0, 0, okay, if I use this triangle. So my vertical height here is 12, and if you want to count it, you can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? So this time I'm going from negative 16, negative 12, to 0, 0. My vertical height of that triangle is 12. The horizontal height was 16, and it simplifies to 3/4. So the point I'm trying to make is this. You can choose any of these 2 points, and you draw the triangle between these 2 points, and the ratio of the vertical height to the horizontal height will be 3/4. That's the slope of this line. Okay, so I want to prove it again to go from this from this point to this point with this big monster triangle, to go from -1612, so I don't have a triangle that they gave me here, -16, -12, to +16, +12. So if I count all of those spaces, my vertical spaces are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So that whole big side length is 24. Then to count the bottom, the horizontal, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So then my horizontal side is 32. So when I take my calculator, remind you guys that you can use your calculator to simplify, and I push in 24, ABC, 32, I get 3/4. Okay, so any 2 points from this line. And the fun thing about this is I didn't show you this, and I've lost triangle B somewhere. All right, so look at this. Those angles right there are the same in triangles A and C. These two angles right here are the same in triangles A and C. And then the right angle is the right angle, which is the same, okay? So these triangles are dilations or scaled copies of each other. Same thing with B. See, the right angle is exactly the same. All right, and then if I line them up over this angle, look at that. They're exactly the same. They're equal, congruent angles there. So we have some angle-angle similarity going on here. Okay, and see there? That angle is also congruent or the same. Okay? Very good. What is the ratio of the vertical change to the horizontal change on triangles A, B, and C? Okay, so let's go back and look at our triangles. I just lost triangle A. All right, so triangle A, the vertical change would be 6. 6 vertical. And then it says vertical change to horizontal change. So 8 horizontal. So we kind of already talked about that in the previous question. And then looking at triangle B. The vertical side for triangle B is 9. The horizontal side is 12. And then triangle C. The vertical side is 12. And the horizontal side is 16. Okay, what is the relationship between these triangles? Kind of already gave that away, didn't I? Okay. They are dilations of each other. Okay, which means their angles are congruent, which I just showed you when I overlapped the angles on the triangles. And it also means, that I didn't talk about this, is the side lengths they're not congruent, they are proportional. Okay, and if all of those things are true, then that means that the triangles are similar to each other. Triangles A, B, and C are similar to each other. Okay? That's a lot, but that's stuff that we learned in Unit 3. Okay? Very good. What connection can you make between similar triangles and the slope of the line? Okay? So if your triangles are similar, there's lots of things we can say. And I'm going to abbreviate triangles with the symbol. If your triangles are similar, then that means the side lengths that we're getting the proportion, the slope from, the side lengths are proportional, and that's where our slopes are coming from. That means the slopes ratio, slope ratio, will be equal to each other. Okay, and that's what I was showing you on that first little slide over here, is even though we have 9 to 12, and 6 to 8, and 12 to 16, and 24 to 32, they all simplified down to 3/4. So that's the slope ratio. Okay? And that's all we have for today. Thanks for listening.